Okay, a very welcome to all of my dear friends and students. So in today's session, we are going to discuss a very important topics of physiology, and the name of topic is action potential in contractile tissue and conducting tissue. So first we try to understand what is the meaning of this contractile tissue and the conducting tissue. Contractile tissue means I will talk about the atrial myocardium and the ventricle myocardiums, and the conducting tissue means Purkinje fibers, bundle of fish, like that. So in today's lecture we are going to discuss how the action potential develops in this conducting tissue and myocardial tissue, ventricle myocardiums and atrial myocardium. So what happens? Initially, the myocardial tissue are at the resting membrane potentials, and the resting membrane potentials of this myocardial tissue is minus 19 millivolts. So what is the meaning of this resting membrane potentials? The resting membrane potential means at this minus 19 millivolts, the net influx of charge is zero. Net influx of charge क्या है? Zero है. So what is the meaning of this net influx of charge is zero? Net influx of charge is zero means the amount of charge entry is equal to amount of charge exits, or in a physiological language we can say that at this point the influx of charge is equal to the efflux of charge. So whatever the amount charge enter inside the cells, the same amounts of positive charge will exit out from the cells at this minus 90 millivolts potentials. So this potential is called resting membrane potentials. What is the meaning of this negative sign? Negative sign indicates that inside the cells having a more negative charge as compared to outside the cell. And what is the meaning of this 19 millivolts? 19 millivolts basically it represent a what? Charge gradients. What is the 19 millivolts? First we try to understand how this 19 millivolt is calculated. This 19 millivolt is calculated with the help of a Nernst equation that you read in your chemistry in standard 12th, or in 12th. So in 12th standard you read about a Nernst equation, that is key at equilibrium we find the electrical potentials will come at the 31 log concentration of ions inside the cells upon concentration of ions outside the cells. So what happens? Scientists calculate the concentration of ions inside the cells and the concentration of ions outside the cells, especially the potassium ion concentration, and on this basis they calculate the value, and that value come is equal to 19 millivolts. So now you can understand how this 19 millivolt value is come. This 90 millivolt value which comes by applying a Nernst equation, in which in the numerator they put the value of concentration of potassium ions. This concentration of potassium ion is approximately equal to 150 millivolts per liters, and the outside the potassium ion concentration value is the 4 millivolts per liter. So when we put this value in this equation, Nernst equation, 61 log concentration of potassium ions inside the cells upon concentration of potassium ions outside the cells, the value comes which is equal to approximately 90 millivolts. So 90 millivolts value which comes by using Nernst equation, and negative sign indicates that inside negative charge are the predominants. And the resting membrane potentials means at this potentials, this 90 millivolts potentials, the amount of influx of charge is equal to the amount of efflux of charge. So this is all about the resting membrane potentials. So after the detailed discussion of resting membrane potentials, now we move towards our main topics, that is action potential generated in a contractile and conducting system, conducting tissue. So what happens? Initially the myocardial tissue, it is let's say atrium myocardium or the ventricle myocardium, they at minus 90 millivolt potential, I mean whatever the amount of charge entry into the cells, the same amount of charge are exits out the cells. There is no any net movement of charge, but as the signals, I mean movement of charge which is generated in SA nodes, they enter into the what myocardial tissue. What happens? This SA node, what happens? SA node having autorhythmicity property. They having a self potential generating property. So when the flow of charge from SA nodes, they enter into the what myocardial tissue. So when the charges enter into the myocardial tissue, now there is a net flow of charges inside the tissue. So whenever there is a net flow of charge inside the tissue, that leads to cause change in membrane potential. So this change in membrane potential will occur. Why this change in membrane potentials will occur? Because there is influx of charge will happen. From where this charge comes? This charge comes due to the depolarization of SA node. So SA nodal cells depolarization charge, they enter into the myocardial tissue. So when inside the myocardial tissue, there is a net flow of charge will occurs. So this net flow of charge leads to change the membrane potentials, and this change in membrane potentials due to influx of charge, and this influx of charge is comes from a SA nodal depolarization. So when there is a net influx of charge will occur, they change the membrane potentials, and they reach the membrane potential at minus 40 millivolts. So at this minus 40 millivolts, what happens? There is the opening of voltage gated sodium channels. So after minus 40 millivolts, there is the opening of voltage gated sodium channels. So due to the opening of this voltage gated sodium channels, now the change in membrane potential is maintained by the opening of this voltage gated sodium channels. And after reaching a maximum value, I mean this voltage gated sodium channels, they are open for a fixed interval of times. So let's suppose they are open for 10 milliseconds. So after 10 milliseconds, whatever the potential achieved, now the voltage gated sodium channels get closed. So as the voltage gated sodium channels get closed, simultaneously or at that times, there is the opening of voltage gated potassium channels. So as the voltage gated sodium channel get closed, at instant there is the opening of voltage gated potassium channels. So potassium ion concentration inside the cell is higher. So whenever there is the opening of voltage gated potassium channels, there is the rapid influx of potassium ion from inside to outside the cell. So this rapid influx of potassium ions is called rapid depolarization or phase 1, and initial this depolarization phase is called phase 0. So after the initial rapid depolarization phases, this phase 0, the next phase will occur is initial repolarization phases, which is due to the influx of potassium ions. So what happens after the initial repolarization phases, after some times now there is the opening of voltage gated calcium channels. After they are opening of the voltage gated calcium channels. So due to the opening of voltage gated calcium channels, now there is the influx of calcium ions, and at the same time so there is influx of potassium ions. So at one side there is the influx of calcium ion, and another hand there is the influx of potassium ion. So whatever the influx of calcium channels will occur, that will neutralize by the influx of potassium channel. So equal amounts of charge are there is the equal amounts of entry of charge and the equal amounts of exits of charge. So when entry of charge and exits of charge both are in equal amounts, so definitely there is no change in potential will occur now. So at this phase there is no any change in potential will occur, and this no change in potential will occur is called plateau phases. So in plateau phases what happens? No any change in potentials. Plateau phases no any change in potentials. No any change in potential. Why in plateau phases there is no any change in potentials? Because whatever the amount of charge entry inside the cells, the same amount of charge will exits out from the cells. So how we can say that there is change in potential, or how the change in potential will occur? Potential change will only occur if there is a net movement of charge in one direction. Here whatever the amount of charge is entering, the same amount of charge will exit out. So it is also a state of equilibrium. There is no net movement of charges. So that things are occurring what this plateau phases. So after sometimes what happens, there is the closing of calcium channels. So after closing of calcium channels, but the potassium channels are still not open. So at this point the calcium channels are closed, but the potassium channels are still open. So now again there is the net movement of charge will occurs, and whenever there is the net movement of charge will occurs, that leads to the change in membrane potentials. So here this now at this phases the change in membrane potential is change in membrane potential is represented by the rate depolarization of the phase 3, and after achieving the resting membrane potential at this point, when the resting membrane when the membrane potential is achieved to a resting membrane potentials, now at this stage there is the closing of potassium channels and the cell is at a resting membrane state. So what happened initially, there is the depolarization phases, then having an initial repolarization phase, then after the initial repolarization phases the cells undergoes in plateau phases. After the plateau phases the cells undergoes in late repolarization phases, and finally the resting membrane potential is achieved. So this is all about the action potentials in conducting systems and what's contractile myocardium. I hope you can understand the lecture. Okay.